Puteri Nurdayana Batrisya, Binti Hasbi, when my metric number S22B0035.
I, Nurul Fatihah, Amani, Binti Azmi, and number metric S22B0013.
And my name is Nurul, Shafiqah, Binti Sari, and my metric number is S22B0009.
Excited to present a comparison of two popular machine learning models, Logistic, Regression, and KNN, K nearest neighbor. Understanding this model help us select the right approach for different problems. We will explain how each model works, their assumptions, strength, limitation, and common applications. Okay, next, what is logistic regressions? Logistic regression is a supervised classification algorithm. It belongs to the linear model family and it's widely used for binary classification tasks such as predicting yes or no outcomes. Next, how logistic regression works. The core idea of logistic regression is to estimate the probability that a data point belongs to a particular class using the sigmoid functions. The sigmoid maps any real value number to a value between 0 and 1, which we interpret as a probability. If this probability is a greater than 0.5, the model classifies the point as class 1. Otherwise, it classifies it as a 0. The result is a linear decision boundary that separates the two classes in the feature space. Next, logistic regression assumptions. Logistic regression assumes a linear relationship between features and the log odds of the target. It also assumes that features are independent of each other and that there is a little multicollinearity. Logistic regression, strength, limitation, and use case. Logistic regression is a simple, fast, and easy to interpret, which makes it useful in many fields. However, it struggles with complex, non-linear relationship and can be sensitive to outliers. Typically, applications include a spam detection, medical diagnosis, and credit scoring.
KNN is an instant-based non-parametric algorithm. It can be used for the book classification and regression tasks by relying directly on the training data without the building an explicit model. KNN predicts the class of the new point by finding the K closest point in the training data using a distance measure, usually Euclidean distance. The predicted class is then decided by majority vote among the disk neighbor. This approach is called the lazy learner because it delays computation until the prediction time. KNN assumptions. KNN assumes that data point close to each other is similar of the class or the value. It also requires the features to be scaled properly because its distance calculation can be biased if one feature has a much larger range than others. Strength, limitation, and use case. So KNN is easy to implement and works well with the complex, non-linear data. Its limitation include being slow with a large dataset, sensitive to irritation features, and requiring significant memory. It is often used in image recognition, recommendation system, and housing price prediction.
This table summarizes the key difference between logistic regression and KNN. Logistic regression is a parametric, linear model that can quickly, easy to interpret, but limited to linear boundaries. KNN is a flexible, non-parametric method that can handle complex patterns but is slower and less interpretable. So in the conclusion, logistic regression is ideal for simple, linear, sparable problem where interpretability is important. KNN excels in capture complex, non-linear relationship but needs careful data processing and can be computationally expensive. Understanding their strength and weakness help us make their modeling choice. Our work is based on academic textbooks, online tutorial, and official documentation to ensure and good accuracy and academic integrity. Thank you.